Hi everyone. In this video I want to show you how to compute the eigenvectors and eigenvalues for a linear transformation. So let's say we have a linear transformation that's represented by a matrix A. So some t of v is equal to A times v. We want to figure out which directions this matrix preserves. In other words, which directions in the plane have this special property that when you take the image of a vector along this direction, the result is a vector that is also along this direction. It's just a scalar times the original vector. So we have A times V is equal to lambda times V, where lambda is just a scalar. Let's think about how we can do this. So first of all, we want to be able to compare apples to apples. So I'm going to rewrite this equation in the following way. And I'm thinking of this as being the identity matrix. So now I have on both sides matrix times vector. Because if I multiply the identity matrix by a constant lambda, the matrix I'm going to get is just lambda 0, 0, lambda. So on both sides now I have a matrix times that vector v. And now I'm going to take an algebraic step and move everything over to one side. And now I have A times that vector minus lambda I times that same vector is equal to 0. And because of the way matrix multiplication and addition and subtraction work, I can actually factor out that vector. I have to keep it on the right-hand side, of course, but I can factor this out. And the result will be this. So now I have the matrix A minus lambda I times vector v is equal to 0. And if our matrix A looks like, say, A, B, C, D, then A minus lambda I looks like this. It's just exactly the same as A, except that the diagonal entries have lambda subtracted from them. So now we have the following equation. And I've written out the entries here, v1 and v2, of the vector v. And this is just A minus lambda I. We're looking for a non-zero vector v and a scalar, lambda, that will make this equation true. So we can remember from earlier times that this is a homogeneous linear system and has non-trivial solutions, that is non-zero solutions, exactly when the determinant of this matrix is equal to 0. So you can go back and look at that everything theorem if you need a reminder about that. So we're hunting for solutions being pairs of vector v and a scalar lambda that are going to make this equation true. So to do that, we're going to take this determinant and set it equal to 0 and find vector v and lambda that will make it true. In the next video, we'll see some examples.